Hi, so today we're going to go over sets and Venn diagrams. So we have set A and B, and we have this Venn diagram, so we're going to put these in. Going to first start off with set A, and we're going to put in the numbers 1, 3, 5, and we're going to exclude 2, 4, and 6 because set B also has those. Okay, so now for set B, we're going to put in, we're not going to put in 4, we're going to put in 8 and 10. And then we're going to put 2, 4, and 6 in the intersecting sector because both sets A and B have them. And so set A will be that circle and set B will be the other circle, and the intersection between them is the intersection between the two sets, and the union represents all the numbers in the Venn diagram. And let's try this with a Venn diagram of 3 circles. So if we have 3 sets A, B, and C with the numbers 1, 2, 3, 4, 5, 6. In set B we have 2, 4, 6, 8, 10. And in set C we'll have 3, 6, 9, 12. And we label the circles C, B, A. And the intersections between 2 circles will be the intersections between like set A and B, or B and C, or A and C, and the one in the middle will be the intersection of all of them. So we're just going to put the ones that aren't repeated into the singular Venn diagram parts. So now we're going to do the sets intersection between set A and C. And if you look at the sets, that would be 3 and not 6, because those are intersecting for A, B, and C. So we're just going to put 3 in the intersection between A and C. And then we're going to have the intersection between set B and C. And as you can see, there would be none because, well, there's 6, but that intersects A, B, and C, so we can't put it there. And then if we have the intersections for A and B, it's 2. So we're going to write that in the intersection, and 4, which also goes there. And as for 6, again, it's intersecting for all 3, so we can't put it there. So now for like the middle part, which is the intersection between A, B, and C, we're going to put in 6 because it occurs in all 3 sets. So that's the intersection between set A, set B, and set C. And the whole entire Venn diagram represents the union of sets A, B, and C. So remember, U is the union between sets, which is the elements from all sets. And then we have the upside down U, which is intersection, which means the overlapping things between the sets. Yeah, oops, I made a mistake. So like the overlapping elements there. And then we have a complement, which is denoted with like the letter and then a small exponent C and it means something that does not belong in the set. Alright, so now we're gonna go over this question. How many subsets are there in a set of size 6? Can you generalize this for a set of any size? So let's start off with set A, which has 6 elements. Let's just call them A, B, C, D, E, and F. So we're trying to find out how many subsets there are in total. Let's just make this set called subset, right? And we're trying to find how many possibilities are there in this subset. Why don't you guys pause the video and see if you can give it a try, and I'll explain it in a second. Alright, so for this problem, you want to think about it as each element of the set has 2 choices, to either be inside the subset or to not be inside the subset. So what we can do is we do 2 times 2 times 2 times 2 times 2 times 2, because we look at, there's 6 elements, right? And each one has 2 choices, so we do 2 to the 6th power, which is going to be 64, which is the answer to the problem. But it also asks for, like, can we generalize this for a set of any size? So if you think about it, it's always going to be 2 choices, in or out. So we will have 2 to the power of the n, which will be the number of subsets there can be. And then n would be the number of elements in that set. Alright, so we have this problem. A survey of 100 people, each whom owns a dog or a cat, both showed that 63 own a dog and 58 own a cat. Based on these results, how many of the people surveyed own both a cat and a dog? So for this problem, we can draw a Venn diagram, one circle being people who own cats, and the other circle being people who own dogs. The problem tells us that, and we're trying to find the intersection between both of them. The problem tells us that there are 58 people who own cats. I should probably extend that to cover the intersection. And there are 63 who own a dog. And in total, we know that there are 100 people. So to solve this problem, we can write an equation which would be equal to 100. So the equation would be 63 plus 58, and then minus the intersection, because that's the overlap, which would equal to 100, and we can just use simple algebra to solve this. So that would be 121 minus x equals 100, and x would be 21. So the intersection between both of them would be 21, which means 21 people have both cats and dogs. Now we can draw a new Venn diagram with our new information. So we have cats and dogs. We know now that there are 21 people with both cats and dogs. There's still going to be, now we know that there's 37 people with only cats and 42 people with. Alright, so now moving on to a more complicated problem. So we have the numbers 1,447, 1,005, and 1,231 have something in common. Each is a 4-digit number beginning with 1 that has exactly 2 identical digits. How many such numbers are there? So we know that this number has 4 digits, right? And we know the first digit is 1. Now if we assume that the last three digits are x or y, and x does not equal to 1, y does not equal to 1, and x does not equal to y. So for now we can say that if the repeating number is 1, then there are going to be 3 different types of number combos. So we're going to have 1, 1, x, y, 1, x, 1, y, and 1, x, y, 1. And to find the number of solutions, we would do 9 times 8 times 3. And that would give us the number of combinations for this set. And we have 3 because there's 3 different combinations, and 9 times 8 for the number of possibilities x and y can be. So what we're going to do now is we're going to multiply the numbers to find out how many combos there are if 1 is a repeating number. And that number would be 216. Now there's a second situation. If x or y is the repeating number, it doesn't matter which one. So let's just say it's going to be x, right? So our 3 possibilities would be, so the repeating number is x, so we'll have 1xxy, 1xyx, and 1yxx. For the same reason, we do 9 times 8 times 3 combinations, which gets us the same number, 216. And to find the total number, we do 216 plus 216, which gets us the number 432.